Chapter 8, Periodic Properties of the Elements. I skipped section 8.1. I don't recall why. Probably be a good idea to read it quickly, but I'm not going to test you on it. Mendeleev. This is a picture of Mendeleev. He was a Russian chemist. Wikipedia is not a perfect thing, but it's a very easy way to get some information. I was looking up something about Mendeleev earlier, and they just got a really nice brief biography of his life and how he was one of between 14 and 17 children in Russia. Back in the 1800s, so conditions there were not great. And his father was a school teacher, but then lost his vision, so lost his job. His mom must have been an awesome lady. She started a glass factory to support the family, but then the glass factory burned down. It's like, wow, what tragedy, right? And so, now they're penniless. But somehow she managed to get him into a university, and he went on to do just amazing, amazing things. So he was studying the elements that were known at the time and trying to look for a way to arrange them that would make some sense and make some order. And so what he discovered is that if you put the elements in order by atomic mass, you see repeating patterns of properties. And so, here's this one, and it does a particular thing with oxygen, and you go along and go down the line 8, and this one acts a lot like that one. And you go down, and the 8th one again acts like the first one and the other one. And he's like, And so he's playing around with it. And this led to the idea of the periodic law. When elements are arranged in order of increasing atomic mass, certain properties recur periodically. That's why it's called the periodic table. Not because it's only a table some of the time, but because it's talking about the periodic repeating of properties of the elements. He ordered by atomic mass. I guess I'm jumping ahead, never mind. So he used the patterns that he saw in his table to predict the properties of undiscovered elements. And there were a couple of places where the atomic mass order didn't fit with the other properties, so he looked at the other properties instead. And tellurium and iodine is one of those examples. If you look at the modern periodic table, period 5, you go along, there's tin and antimony. Tellurium has a mass of 127.6, and iodine has a mass of 126. Iodine's mass is actually less. It's out of mass order. But Mendeleev put them in that position because it made more sense with their properties. Iodine behaves like the other elements in its column. So here's an example of two of the elements he predicted. So when it was discovered, it was named gallium. He named it Eka aluminum, and germanium, which he called Eka silicon, because it was one below silicon on the table that he had. So, looking at his predicted properties versus the actual properties. And it's really very amazing. You got the formulas for the oxides and chlorides, right? The densities, remarkably close. Had ideas about the melting point. Gallium, by the way, is very, very cool. The actual melting point of gallium is 29.8 degrees Celsius. So that's below body temperature. So gallium is a solid at room temperature, but if you hold it in your hand, it melts. Is it? Probably, yeah. It's just very, very cool. Awesome. We should buy some. I wonder if there's some in the stock room. I don't know. I'll look. And here's germanium. And again, really, really close to the properties. I just think that's pretty amazing. He took this jumble of elements, found a way to order them, and then predicted, hey, there's a hole here. I bet there's an element there, we haven't discovered it. And then he actually predicted what it would be like. The periodic law is a law. Remember, laws tell us what happens, they don't explain why. It allows us to predict what the properties of an element will be based on its position in the table, but doesn't explain why the pattern exists. Quantum mechanics is a theory, and it's a theory that explains why those periodic trends in the properties exist. And this is a very common order, that knowing why allows us to predict what, but if we don't know what, we can't figure out why, right? So first comes the what. Oh, this happens. Then people try to figure out why. Once we figure out why, then we can predict what will happen in other situations.